In this training, we'll be covering the basics of combustion, including terminology, types of heaters, types of heat transfer, an introduction to fuel types, and heater control systems. Combustion is a reaction between three chemical reactants. These three chemical reactants are fuel, oxygen, and an ignition source. If one of the reactants is missing, you will not have combustion. For instance, if you open a propane tank but do not have an ignition source present, you will not have combustion. Likewise, if you have a spark but no fuel, you will not have combustion. There are two types of combustion. Ideally, the mixture of air and fuel would be perfect, thereby causing a complete combustion when ignited, which means the byproducts of the combustion are only heat, H2O, and carbon dioxide. However, when the mixture of air and fuel are imperfect, the combustion byproducts are heat, H2O, carbon monoxide, carbon dioxide, and other gases. This is known as incomplete combustion. These byproducts are harmful to humans. This is why proper ventilation is necessary when using a direct-fired heater. On a side note, we at LB White strive to engineer products that are as close to perfect combustion as possible, thus producing as few byproducts as possible. Another element of combustion to keep in mind: as the installation goes up in elevation, for instance on the West Coast, in Canada, or in Mexico, you need to make a change to a heater to meet the elevation because of the decreased amount of oxygen. What that requires is a downsizing or re-rating of the main orifice of the heater. Some things that can happen if this doesn't occur is the high limit switches can trip because they are being overfired, there will be poor combustion, and the heater may start deteriorating earlier. Heaters must be derated at elevations greater than 2,000 feet, and the heater is derated 4% for every 1,000 feet greater than 2,000 feet. Now we're going to talk about some basic terminology when talking about heaters. BTU is short for British Thermal Unit. It's the amount of energy that is needed to rise 1 pound of water by 1 degree Fahrenheit. 1 BTU is approximately equal to the energy released by burning a single match. CFM, cubic feet per minute, is a measure of airflow. For example, a fan with 1,000 CFM can remove all the air from a 10 foot by 10 foot by 10 foot box in 1 minute. Carbon monoxide, or CO for short, is a poisonous gas that is produced when fuels such as natural gas or propane burn with insufficient air. This is one of the byproducts of combustion mentioned earlier. This poisonous gas is odorless and colorless and is harmful to humans when inhaled in large amounts. Dual fuel. This refers to heaters with the capability to alternate between liquid propane gas, LP, or natural gas, NG fuel, without needing a conversion kit. For instance, a dual fuel heater can be very beneficial on a construction site where there may not be an NG source available yet. However, the heater can be set to LP first with a propane tank brought in, and once natural gas becomes available, the heater can switch to NG by means of turning the lever inside the heater to operate with NG. Ductwork is a system of metal or plastic ducts used to transport the heated air from the heat source to another location. A thermostat is a device that monitors the temperature and automatically adjusts your heating system to maintain your desired level. Now we're going to talk about types of fuels and types of heaters. There are three main types of fuel LB White uses. One is liquid propane gas, which is colorless, odorless, and heavier than air. Another is natural gas. This is a fossil fuel which occurs naturally in the earth. Natural gas is lighter than air. A man-made odor is added to these gases so you can smell them for safety reasons. Propane burns hotter than natural gas, 2,500 BTU per cubic feet versus natural gas's 1,000 BTU per cubic feet. So, when you are running LP gas, it will burn much hotter. For this reason, different orifices are used for LP versus NG to allow the correct volume of fuel to come through for the correct BTU output. The last we refer to as oil, which can be kerosene or diesel. Kerosene is a light fuel oil obtained by distilling petroleum, used especially in jet engines and domestic heaters and lamps, and as a cleaning solvent. It condenses at a temperature intermediate between diesel fuel, which is less volatile, and naphtha and gasoline, which are more volatile. Diesel fuel is produced from various sources, the most common being petroleum. Other sources include biomass, animal fat, biogas, natural gas, and coal liquefaction. Direct-fired versus indirect-fired. With direct-fired heaters, air is forced through the flame, heating up the air. Direct-fired heaters are 99.9% fuel efficient when considering how much of the fuel is turned into usable energy, or heat in this case. With these heaters, proper air exchange through ventilation is required. With indirect-fired heaters, this is the type of heater used in most residential houses, the flame is contained in a confined space or heat exchanger. Air passes over the heat exchanger and is heated indirectly by the hot metal. The byproducts are then exhausted through the chimney, so you can just have warm, dry, clean air. Indirect fired heaters are about 80 to 95% fuel efficient, since about 5 to 20% of that heat is going out the chimney along with the byproducts of combustion, which can be poisonous. And lastly, our heaters are developed to meet or exceed stringent requirements set forth in the codes and standards of OSHA, NFPA, ANSI, and OMNI. There are 3 types of heat transfer. These types are convection, conduction, and radiation. Convection is when heat passes through a fluid or gas. Some of our convection heaters include the Guardians, Classics, Premiers, Tradesmans, Bosses, Blooms, Thermogros, Workmans, Norsemans, and Commanders. Conduction is when heat is transferred through direct contact with objects that are touching. Some LB White heaters using this type of heat transfer are the Foreman and Journeyman families. And lastly, radiation. This type of heat transfer is like the sun. Heat moves through space to an object. Some of our heaters that use this type are brooders, tube heaters, and sun blasts. Now I'm going to give an introduction to fuel types. Propane gas is available in compressor tanks and comes in various sizes, anywhere from 10 pounds to 2,000 pounds. Our torches and Premier 40 can run off a 20-pound propane tank. Everything else we recommend higher than 100 pounds, depending on how long you want to run the heater and your heat demand. If you want to figure out your fuel consumption, you take the total BTUs for the heater you are using, divided by either 91,502 gallons per hour or 21,548 pounds per hour. So if someone has a 20-pound cylinder and they are using the Premier 40 at 40,000 BTUs, you will take the 40,000 BTUs divided by 91,502, which equals 0.44 gallons per hour. The propane tanks are usually about 80% full, as some space is needed left at the top of the tank to allow for expansion. A 20-pound tank holds 4.5 gallons of fuel. Now take the 4.5 gallon divided by 0.44 gallons of fuel consumption. This will tell you how long you can operate the Premier 40 on a 20-pound propane tank, which in this case equals 10 hours of runtime. The other gaseous fuel type is natural gas. Natural gas comes from an underground service pipe from the city. Natural gas pressure can be anywhere from 60 psi down to as low as 0.25 psi or 7 inches of water column. When we are talking about gas pressure, there are 2 units of measure: inches of water column, inches WC, and pound per square inch, PSI. Inches of water column is considered low pressure. Most heaters operate on low pressure ranging from 7 to 13.5 inches water column. There are 28 inches of water column in 1 psi. 1 psi and greater is considered high pressure. To reduce the high pressure down to low pressure, you'll use a regulator. A regulator is a control valve that lowers the input pressure to a desired value at its output. We will explore more about regulators shortly. Our third fuel type is kerosene. Kerosene can be purchased at local gas stations and home improvement stores like Lowe's. Diesel can be found at gas stations. Both can be purchased in various size containers. One may be used over the other because of availability in different regions. Kerosene can be more expensive than propane, but it may cost less for heating when you factor in that heating efficiency. Oil heaters don't require regulators to manage the fuel, but rather fuel pumps and nozzles. Before we come back to regulators, I would like to go over some safety guidelines related to fuel. All fuel types require proper storage and handling. Refer to a heater's data plate for the proper fuel to use. Always check for gas leaks in the heater and gas supply system. Proper oil or gas pressure must be supplied. All installations must meet applicable codes and standards, which may differ by region. And consult the heater's owner's manual, a local fuel supplier, a government agency, fire department, or LB White tech support for any questions related to installation. Back to regulators. There are different types of regulators. Single stage. This regulator reduces the tank pressure to low pressure. First and second stage regulators. This involves a two-regulator system. The first stage regulator reduces the tank pressure down to 5 to 20 psi. The second stage reduces this pressure to the heater operating pressure, inches water column. And lastly, twin stage regulators. This involves one regulator performing both the first and second stages of operation using a two-regulator system in one regulator. There are two types of heater controls used on our products. The first is a thermostat. A thermostat is a device that monitors the indoor temperature in relation to your desired temperature and will automatically turn your heater on or off. This works like a light switch, but operates automatically based on the temperature. The second is a building controller. This is a control panel used in agricultural applications. They will control the building's ventilation system, feeding system, water system, and heating system, either through a timer or temperature sensing. This too will turn the heater on and off, or in some cases may push certain voltages to a heater to allow modulations of heat.